Hello everyone. In the last class, we were studying about highest common factor or HCF for a given numbers. And in today's class, we are going to learn what is meant by least common multiple or LCM for a given numbers. You have already studied about least common multiple in your smaller classes, and in today's class, we will be discussing two methods to find out the LCM. Now consider the numbers 8 and 12. Now, which are the multiples of 8? Multiples of 8 are 8, 16, 24, 32, 40, 48, etc. Now, which are the multiples of 12? Multiples of 12 are 12, 24, 36, 48, etc. Now, if you look at the multiples of 8 and 12, you can see that some of the numbers or some of the multiples are common. Now, which are the common multiples? Yes, 24 is a common multiple, 36 is a common multiple. Like that, we can find so many common multiples for 8 and 12. But among the common multiples, which is the least one? Yes, 24 is the least. So, we'll say that the least common multiple of 8 and 12 is 24. Also see that this 24 is the least number which is exactly divisible by 8 and 12. So we can define the least common multiple for a given number as the least common multiple of two or more given numbers is the least number to be exactly divisible by each one of them. So using this way, we can find out the least common multiple for a given numbers. But we usually use other method to find out the least common multiple, and two of the method we are going to study now. Method 1, prime factorization method. So let us take the same example, find the LCM of 8 and 12 using prime factorization method. So in this method, first of all, we need to prime factorize both the numbers. So we need to prime factorize 8 and 12, and you have already studied how to prime factorize numbers. So using the division method, we will prime factorize both 8 and 12. So we will get 8 is equal to 2 into 2 into 2 and 12 is equal to 2 into 2 into 3. So this is the first step. Now look at the prime factorization of 8 and 12. And we have only two factors, two prime factors. They are 2 and 3. And the number 2 has appeared 3 times in the prime factorization of 8. And the number 2 has appeared 2 times in the prime factorization of 12. And the maximum number of appearance of 2 is 3. Since 2 has appeared 3 times in 8. So the maximum number is 3. And take the next prime factor, that is 3. And 3 has appeared only 1 time in the prime factorization of 12. So we will take the product of these numbers, that is 2 into 2 into 2 into 3. That is equal to 24. So 24 will be the LCM of 8 and 12. Now let us learn the second method. And this method is called division method. And let us take the same example, find the LCM of 8 and 12 using the division method. In this method, what we do is, we will write the numbers in a row by putting commas. Then we need to find out the least prime number which divides both 8 and 12. And we know that 2 is the least prime factor of 8 and 12. So we will divide both the numbers by 2, and 4 2s are 8 and 6 2s are 12. So we got the numbers 4 and 6, and we need again to find out the prime number which divides both 4 and 6. And we know that 2 is the prime number which divides both 4 and 6. So we again divide 4 and 6 by 2, and we will get 2 and 3. Now there is no common factor for 2 and 3. So we will stop the division process here. Then the product of the divisors and the remaining number we got will be the LCM of 8 and 12. That is LCM of 8 and 12 will be 2 into 2 into 2 into 3. That is 24. Let's do one more example. Find the LCM of 15, 18, 36 and 45 using the division method. So first of all, we need to arrange the numbers in a row by putting commas. Then we need to find out the prime number which divides at least 2 of the given numbers. And if you look at the numbers 15, 18, 36 and 45, 18 and 36 are divisible by the prime number 2. So we will divide these numbers by 2. And we know 15 is not exactly divisible by 2. That is, 2 is not a factor. 2 is not a prime factor of 15. So in that case, what we do is, we will bring down the number 15 as it is. So 15 we will write as it is. Then 9 2s are 18 and 18 into 2 is 36 and 45 is not divisible by 2. So we will write 45 as it is. So we got the numbers 15, 9, 18 and 45. Now again we need to find out a prime number which divides at least 2 of these numbers 15, 9, 18 and 45. And we can all take the prime number 2 because 2 is a factor of only the number 18. So we will take the next prime number, that is 3. And 3 is a factor of the numbers 15, 9 and 45. So we can divide these numbers by 3. So we will write 3 and 5 3s are 15, 3 3s are 9 and 6 3s are 18 and 15 into 3 is 45. So we got the numbers 5, 3, 6 and 15. And again we need to find out the prime number which divides at least 2 of these numbers. And 3 is a factor for the numbers 3, 6 and 15. So we can take the number 3 again, and since 5 is not divisible by 3, we will write 5 as it is. Then 1 into 3 is 3, 2 into 3 is 6 and 5 into 3 is 15. So we got the numbers 5, 1, 2 and 5. And you can see that the number 5 has occurred 2 times. And the prime factor of the number 5 is 5 itself. Since 5 itself is a prime number. So we can divide the numbers by 5. And 1 into 5 is 5. And 1 is not divisible by 5. So we will write 1 as it is. And 2 is also not divisible by 5. So we will write 2 as it is. Then 1 into 5 is 5. So we got the numbers 1, 1, 2 and 1. There is no common factor except 1 for at least 2 of these numbers. So we will stop the division process here. Then the product of the divisors and the remaining number will be the LCM for these numbers. So the LCM of 15, 18, 36 and 45 is 2 into 3 into 3 into 5 into 2. And that is 180. So that's all for today's class. See you in next class. Thank you.